Welcome to SA Engineering College Gate Coaching video. This is Nithyasundaри, Department of ECE at SA Engineering College. The topic is Fourier series and Fourier transform. In the previous video, we have seen about the Fourier transform formula, Fourier transform problem. In this video, we are going to see about the Fourier series and Fourier transform problems. Now we'll move on to the problems. So the first problem is an ideal low pass filter has frequency response given by h of j omega equal to 1 for the modulus of omega which is less than or equal to 200 pi, 0 otherwise. Here h of t is the time domain representation. They asked to find out the h of 0 value. So first, in the first step, we need to write the inverse Fourier transform formula. We know the inverse Fourier transform is h of t equal to 1 by 2 pi minus infinity to plus infinity h of j omega e power j omega t d omega. So in this, the h of j omega value given which is equal to 1 for the integral value for the range from minus 200 pi to plus 200 pi. So in the next step, the question is to find the t equal to 0 value. So substitute t equal to 0. Substituting t equal to 0 in this so in the formula, it will become t equal to 0. Here we need to substitute t equal to 0. So we know that e power 0 which is equal to 1. So after that we need to perform the integrations. So performing the integration, we know that integral of 1 d omega which is equal to omega. So after integrating, we need to substitute the limit. So the lower limit is minus 200 pi and the upper limit is plus 200 pi. So substituting the limit, it will become 1 by 2 pi, 200 pi to minus of minus 200 pi. So here in this minus into minus which is equal to plus, this will give 400 pi. So strike outing the numerator and denominator, this pi and pi will get cancelled and this 1 with here it is 200. So the value, final value of h of O which is equal to 200. So here the h of 0 which is equal to the h of 0 which is equal to 200. So this is the final solution, final answer for the h of 0 value. So the next problem is, it is given the discrete Fourier transform of a signal x of n is h of omega so h of omega which is equal to 1 into 1 plus cos omega into e power minus j omega. Consider here xp of n which is the periodic signal of period n equal to 5. xp of n is the periodic signal that representing x of n. x of n periodic signal which is denoted as xp of n whose period is given as n equal to 5. So here in this the value x of n is given as for xp of n which is equal to x of n for the n value 0, 1, 2 and for 3 and 4 the value is 0. So we know that the Fourier series formula is xp of n which is equal to summation of ak e power j 2 pi n into kn. Here in this ak is nothing but the Fourier series coefficients. So the question is to find the magnitude of the Fourier series coefficient a3. So a3 is nothing but the Fourier series coefficient. So in the previous slide it is given the same thing. Here it is mentioned xp of n equal to x of n and for the value, and here we know that x of n whose discrete time Fourier transform is x of omega whose expression is whose expression is 1 by 1 plus cos omega e power minus j omega. So here the Fourier coefficient formula is ak equal to x of 2 pi n k divided by n. So we know that in the question it is given x of omega equal to 1 plus cos omega e power minus j omega. So omega value is 2 pi k by n. This is the omega value. So omega equal to 2 pi k by n, and this is also omega 2 pi n by 2 pi k. This is not r, this is k. So 2 pi k by n divided by n. So we know that it is given as period as capital N equal to 5, and k in the Fourier coefficient it is mentioned that k value which is equal to 3. So substituting the n value and k value in the above expression, we will have a3 equal to 1 plus cos 2 pi, and k value is 3 and n value is 5. And into e power minus j 2 pi, and k value is 3 and n value is 5. So substituting all these divided by 5, which is equal to, in the question it is asked to find out the magnitude of Fourier series coefficient. So we need to find the modulus of a3. So modulus, when considering the when taking modulus, this exponential term will get neglected. So it is 1 by 5 into 1 plus cos 6 pi by 5. So solving this whole thing will give the answer 0.0382. So this is the final answer. So the magnitude of the Fourier series coefficient A3, which is equal to 0.0382. Now we'll move on to the next problem. So problem 3 is, considering a continuous time signal x of t equal to minus t square into u of t plus 4 minus u of t minus 4. Here u of t is the continuous time unit step function and del of t be the continuous time unit impulse function. The value of so in this it is given that they have asked to find out x of t del of t plus t dt, the value. So here given that x of t equal to minus t square u of t plus 4 minus u of t minus 4. So this represents a time limited signal that exists only between minus t4 to plus t4. So it is range from minus t4 to minus 4 and plus t4, that is u of t plus 4, u of t plus 4 which is equal to 1 for t greater than or equal to minus 4. Then next one, u of t minus 4. So u of t minus 4 which is equal to 1 for the t greater than or equal to 4. So the value of this one exists from minus 4 to plus 4. So this signal, this x of t signal exists between the range from minus 4 to plus 4. So this one is given here. This signal exists only between t equal to minus 4 and t equal to 4. Otherwise this integral which is equal to 0. So in the question they asked to compute integral of x of t del of t plus 3 dt. So we know that the shifting property of the delta function, which is when the signal is multiplied to the time shifted impulse signal, then this one shift the signal t to t naught. So in the question they asked to find del of t plus 3. So when substituting here del of t plus 3. So when del of t plus 3 is multiplied to the signal, when taking integral, it change the signal to f of minus 3. Same as this one. So instead of t naught, here the t naught value is minus 3. So substitute t naught which is equal to minus 3. So substituting, so in the second step, we need to substitute t equal to t equal to minus 3. So substituting t equal to minus 3 in this expression. So in this expression it is u of minus 3 plus 4 which is equal to minus 3 plus 4 which is equal to u of 1. U of 1, the signal exists from minus 4 to plus 4. So u of 1 which is equal to 1 and u of minus 3 minus 4. Here substituting minus 3 it will become minus 7. So u of minus 7 is, it exists between minus 4 to plus 4. So minus 7 will become 0. So substituting these values u of 1 1, u of minus 7 which is equal to 0 in the above expressions. So we know that t equal to minus 3. So minus of minus 3 whole square into 1 minus 0 which is equal to minus 9. So 3 into 3 it is 9. 9 into 1 is 9, minus 9. So the final answer is x of t del of t plus 3 dt which is equal to x of minus 3, this x of minus 3 which is equal to minus 9. So the final answer is minus 9. Now we'll move on to the next problem.
Yes, sir. Yes, sir.
So the fourth problem is the Fourier transform x of omega of x of t as e power minus t square is. Here they asked to find out x of omega for the given signal x of t. Here the assumptions given is integral of minus infinity to infinity e power minus y square dy equal to e power minus y square dy which is equal to square root of pi. So this is the assumptions given. So these are the options we needed to find the answer. So we know that the Fourier transform formula is x of omega equal to minus infinity to infinity x of t e power minus j omega t. So here in this we needed to substitute in the given question. In the question it is given. So in the question it is given x of t equal to e power minus t square. So substituting this when taking integral, notice that this integral can be rewritten by combining the expression. So here in this there are two exponentials, so we can combine these two. So when combining these two it is minus t square minus j omega t dt. So after this exponential part alone can be rewritten as, so here it is t square minus j omega t which is equal to, so this one, so this can be, take out minus sign outside, it will become minus of t square plus j omega t. In order to make this one, this exponential simpler, we are simplifying this by rewriting this, by this expression can be rewritten as for the simplification process, plus omega square by 4 and minus omega square by 4, these terms are included in order to make the expression simple. So this one, now this one will become, now this one is in the form of a plus b whole square. Now this can be written as t plus j omega whole square minus omega square by 4. Now we need to substitute all these here in this place. So here we have substituted in the exponential part t plus j omega whole square, j omega by 2 whole square minus omega square by 4. Here in this term we are taking out the constant outside. This term does not contain a t value, so we can take out this one is considered as constant, so we can take out the constant outside. So e power minus omega square by 4, integral of minus infinity to infinity e power, so the remaining part is minus of t plus j omega by 2 whole square dt. So after that, since the integral is in the form of the Gaussian integral and we know that the shifting the integration variable does not affect the value of the integral. So here in this, it is e power minus t j omega whole square dt. In the question it is given that this portion which is equal to this one, so this one which is, it is given in the question that this one e power minus omega square dy which is equal to square root of pi. So this one is given in the question. So now we can consider this part which is equal to square root of pi. So substituting that one which is equal to square root of square root of pi. So the Fourier transform of x of t equal to e power minus t square as they asked to find out e power minus t square signal Fourier transform. So x of omega equal to square root of pi e power minus omega square by 4. So the final answer is for this one, the option C is the correct answer. So square root of pi e power minus omega square by 4. So thank you. We'll see in the next video.